solutions. As you can see, we have solved all the way to problem number 35, as well as we've solved problem number 67. So in this episode, we are going to solve one or two problems depending upon how much time we have, and let's get on with it. Just want to remind everyone that if you like these problems, please consider subscribing. It will help my channel a lot. But anyway, let's start with the next problem. So the next problem, let's create this problem 36. So let's create a new Jupyter notebook, and let's try to solve this problem. Okay, so that's problem 36, and problem 36, and this is called double-based palindromes. It looks like that. Okay, and let's copy the problem. So the problem states that the decimal number 585 in when we talk about decimal, we just mean base 10 is okay. So we need to do something about that. Okay, 585 in base 10 is equal to that number in binary, and is palindromic in both cases. So this is palindromic and this palindromic. Okay, find the sum of all numbers less than 1 million which are palindromic in base 10 and base 2. Okay, please note that the palindromic number in either base may not include leading zeros. Okay, so it seems to be a relatively easy problem. We just need to find all numbers less than 1 million. 1 million in any case is not a palindromic number. So we go from n equals, we go all the way to, let's go to a small number, and then we will increase the total number later. 0 is actually a palindromic number in both cases, but we won't care about it simply because of the fact that it is adding 0 to anything will not change anything. 1 is a palindromic number, so 1 in binary is also equal to 1, and so it's supposed to be palindromic. I'm not entirely sure if one-digit numbers count in this case. I don't see anything over here that explicitly says that one-digit numbers cannot be a palindromic. So 1 is a palindromic number. In this case, we will go from 1 and all the way to n plus 1, and let's put 99 in this case. Okay, so that's a set of numbers that go from 1 to n, and we want to check whether each of these things are palindromic. So we will create another function that will just check if a number is palindromic. So, and we take a number n of type int, and this is going to return type bool. If it is palindrome, it's going to return a yes. If it is not a palindrome, it will return a no. And we'll just say n is string n, and str is that, and if n str is equal to so I'm going to use a function reversed. Okay, 1 2 2 1. Okay, so if I do reversed, it is going to reverse this number, but it is also going to convert this into a into a list. Okay, so we have to so it's also going to convert it into a list. Okay, let me just into a list, and so we want to join it back, so you can do join like that and it will concatenate it back. So that's basically what I'm doing over here. So join reversed and str, if those two are the same, return true, because that is a palindrome, otherwise return a false. Okay, so that's a number that will check whether that's a number that will check whether something is a palindrome or not. Okay, so given that, we want to filter all numbers that are palindromes. So the way we do that is by using a filter, I think. I don't know whether this is going to work. Filter is how. So these are all the palindromic numbers. So we don't have to worry about numbers that are not palindromic. So the reason for using this is because this is an iterator, and that will mean that you are not, this is an iterator and this is an iterator, so you are not keeping things in memory. Okay, all right, so these are palindromic all the way to whatever number you provide. And the next thing to do is to check whether its binary form is also palindromic. So how do we do this? We have to take this number and whatever it is and convert it into its binary form. There are algorithms to do it, but the easiest thing to do is to just use whatever Python has. So Python number binary string, right? So if you see this, you will see that if you have a number in this form, then it is going to give you the number in a binary string. So the easiest thing, so you can use an f string and use the b at the end to create a binary string. Let me explain what that means. So this is a string. If you have a number n is 50, for example, then you can put that in as that, and it will add 50 in like that. So it will add whatever the value is for n inside there. That's a that's an f string. It will convert the rest of the thing into a string, and you put b over here, that will make it a binary string. Okay, so any number, if you want to convert it into binary, all you have to do is put it in an f string and say I want the binary representation of that. And if you put a number like 585, for example, 585, it's going to give you the binary representation, and you can check whether it is integer or not. Okay, all right, so we want to check also whether this number in its binary representation is a string or not a string. In its binary representation is palindromic. So this number binary will look like this. I in its binary representation. Let's print it. So let's give it some space, like 5D or 6D, and right justified. Okay, and we will also print its this is supposed to be an F string, so it's supposed to be its binary representation, so it looks like that. So we have the numbers and the binary numbers as well, and we want to check which one of these are actually palindromic. We know that these are palindromic, the ones on the left, but we want to know which ones on the right are also palindromic. And the way we check it is if I bin, so is the same as reversed I bin, not ibon but I bin, and we want to make sure that we join it into a single string. Join like that, then we print this. Right. So we have a few numbers. Let's go up to 999 to make sure that we get that 585. We do have 585, so it looks like it's something that's working. We are going to now just sum up the numbers. I believe that's find the sum of all numbers. So n sum 0. If we are over here, then we just want to do n sum plus equal to 1. And that's it. We just print n sum, and we can check what the result is. The result is 10. Let me just print. I print I. So up to 999, the value is the sum of it is 1772. Okay, if we go all the way to 1 million, that's 1 with 6 zeros. I believe that should be the answer. Let's see. All right, so we have solved this problem. Please check in again for the next problems, and I will see you there. Bye bye.